Hello everyone, I'm Luke, and in this video I'll tell you how I created my very own dialogue system in Unreal Engine. It's going to be one of the most important systems in my game, so I decided to create it before importing my own assets. So, for the time being, I'm using Unreal Engine's starter content and some super high quality sprites I created in about 1 minute. But first, with this kind of task, you need to do some research and have a general overview on where this system fits in the game's ecosystem. First, let's ask ourselves, what is a dialogue system? Generally speaking, it's a storytelling tool. Sure, dialogue system may also be used to interact with merchants or pick a quest reward, but there are simpler ways to do that. For example, you might replace a merchant with a vending machine, or place reward items on pedestals so that when player picks one, all others disappear. So before even attempting to create the system, I had to ask myself, what storytelling features do I want in my game and how do they fit together? Generally speaking, there are 3 main ways to do storytelling. Dialogue, where characters simply talk to each other. Scripted events, where some event happens when the player meets the conditions, such as walking through a certain spot on the map. And environmental storytelling, most prominent in the Dark Souls series, where story is told by environment and item flavor text, and then made into a real story by YouTubers. The environmental storytelling uses other systems, such as level layout and inventory system, so I don't need to think about it when creating my system. But we want dialogue and scripted events to either work alongside each other or seamlessly transition from one into the other. From here it's a relatively simple design. I created a class for interactable objects and then I created 2 child classes, one for dialogue and one for scripted events. The main parent class doesn't have any real functionality, but designing the system that way gives me an easy way to select all interactable objects in the level, which comes in handy when loading assets or simply selecting the one object the player interacts with. I also used something called blueprint interfaces, which simply gives me more flexibility while saving up memory, as it doesn't require any hard object references. It can simply send a message to everything around the player, and only the interactable object will respond. And now, once the groundwork is complete, and we know the dialogue system place in the game's ecosystem, we can finally approach the question: how exactly will my dialogue system work? So once again, let's turn to other games and simply get inspired by someone else's ideas. Basically, there are 3 most common approaches. The first one is dialogue along dedicated scripted events, where talking to NPCs looks a bit like a movie. Their lips are moving, there may be dedicated camera angles or scripted events happening alongside the dialogue. This approach is best seen in CD Projekt Red's games, such as The Witcher or Cyberpunk. The solution looks great, but it takes a team with lots of talent, experience and resources, and I'm just a single, not particularly smart guy, simply trying to entertain the 2 random people that will actually play my game. So let's go to option number 2. The second one is in-game dialogue. Talking to NPCs simply creates an overlay on your screen, as everything in your surroundings simply goes about its business. There are no dedicated camera angles or any fancy stuff, although generally in most games the NPC and the player character have some kind of animation to visually indicate that an interaction is taking place. The examples of such dialogue might be Hollow Knight, Dark Souls and Blue Fire. However, this solution gives the player time to look really close at the models, and it takes some skill to create nice interaction animations. 3D modeling is one of my weakest skills when it comes to games development, so I'd rather avoid doing anything that lets the player realize just how bad the models look. Also, in my game I'd like to use a lot of facial expressions to better entertain the player, and this solution doesn't really allow that to happen, or makes it quite difficult. Which brings me to solution number 3. Just a virtual novel. That's right, Even if the game is not a virtual novel by itself, it can use the entire dialogue system right out of a VM. In that case, you would pause the game or ensure that the player is safe. Then launch a virtual novel segment with character sprites, a text window with the character's name, and every once in a while a choice might pop up. Implementing that solution also gives you access to another storytelling tool, computer graphics, or CGs. You simply display an image and let the dialogue run while that image is active. It can replace some scripted events and is far less time-consuming than creating an entire scripted sequence. It also allows me to hide some 3D modeling flaws by letting me modify the sprites in Photoshop, and an amateur like me should use every dirty little trick available to raise the enjoyment factor of the game while minimalizing development effort. And so I chose option number 3. Of course, designing such a system still isn't easy, especially if you want it to look decent. But it saves a lot of time by using poses rather than animations, while retaining a lot of expressiveness when paired with clever character design, but more on that in another video. And so, after all that research and planning, it was time to do some actual work and game development. An MVP means a minimum viable product, which means it's a solution that's not ideal, but if you find yourself out of time and money in the middle of a project, you can just go fuck it, let's just use what we have, as it employs all the core functionality that the product needs. Let's go over the general architecture. When the player is within a certain distance from an interactable object and presses the correct key, the interaction begins. It doesn't pause the game, so as the dev I must ensure that the place of each interaction is safe. Then the dialogue system actually takes effect. It immobilizes the player and camera while allowing the mouse cursor to interact with the VN overlay. Then it creates such an overlay, which consists of a text box, character name, container for character spirits, and a CG image. Then the object takes in a data table, reads it row by row, and populates the overlay's components based on current row's data. Once the segment ends, it either returns control to player or starts interacting with another interactable object within the level. This allows me to chain interactions without player input. So my first task was to get the VN overlay to actually work and make sure that the interactable object is capable of connecting with its data table and using its data to populate the overlay. So here's what the test data table looked like. We have the row name, which is used to reference rows in the object, the name of the speaker, text, sprites in the scene and their scale, which lets me set the ratio of how much screen each sprite occupies. Text supports tags, such as bold, which can alter the way the text looks, including font, color, or size. My game will have a lot of text, and I want the player to always have clear directions where to go, and I can accomplish that by giving direction-specific text a distinct style. Speaker name also allows such styling, should I ever feel like a character deserves a custom font. Then I created a function to populate the overlay based on the row index, which is stored in the object as a variable. The function is called either by other functions or anytime the player clicks a left mouse button during a VN segment with no active choices. The function breaks the row into values, sets the speaker name, text, and then if the sprites changed since the last row, it creates a sprite for each element in the array with its respective scale. If the row index is not found in the table, the segment ends. And here's how it looks in practice. I know it's ugly, but beautifying the solution comes last. For now, I just want to make sure that all the objects communicate properly to ensure a working gameplay mechanic. The next step was to implement CGs, which meant adding special commands to the data table. They allow me to show image, hide image, or end the VN segment, which gives me more control over the flow of the dialogue. And the last thing on our MVP list is a working choice system. What it does is it creates another overlay and populates it with data from a data table. When I click the button, it sends its text back to the object, which can use a map created earlier to retrieve the correct target row number. Here's the data table for our MVP. You can see me using all the special commands I have at the moment to show and hide the image, to handle the choice, and to exit the VN segment, rather than let it run until the refresh function fails to find a row with a specific name. Choices, images and sprites use soft object references, which means the code will try to load anything I write. While it forces me to be very careful about the way I spell things, it gives me much more flexibility than hard references to specific assets. Implementing all of that took me about a week, with varying hours each day, depending on how much free time I had. And now that I had my MVP, it was time for the hard part, making it all look nice, or at least not awful. You may be wondering, how come making it look nice is the hardest part? You see, the relatively easy part of beautification is replacing ugly default assets with pretty images and making assets slowly fade in rather than instantly appear. Now, the hard parts. See how the sprite that stays the same changes opacity once another sprite is loaded? Yeah, fixing that requires massive changes to the sprite loading system. And see how the text appears instantly, rather than slowly appear like it does in all other virtual novels? That requires me to load the text in small steps, which is relatively simple, unless you're using style tags.
Fuck.
The first problem I had to address was some kind of weird bug or something. Every time I turned on Unreal Engine, I had to copy the asset reference for it to actually load in the VN segment. Of course, the player can't go into the editor to copy the reference, so I had to do something to fix this issue. I couldn't find any information on that problem, so I just assumed that the engine is unable to load the assets fast enough, which causes a glitch. So I created an asset loader system that fires off when the player is close enough to the object. It also deloads the assets when the player gets far away to save memory. To my surprise, it actually worked. The only problem is that it causes a short game freeze the first time it goes off after turning on Unreal Engine. I have no idea how to prevent that, so instead I added a custom event node, which allows me to start the loader anytime I want, for example during a level loading screen, when the freeze doesn't affect gameplay quality. It's possible that when I create a bigger level, I'll have to come back to this system to optimize it, but I'll tackle that problem when the time comes. Now, let's get back to the characters and adding fade-in effect. The effect itself is simple enough. I just need to change the opacity by a small amount in a very short time intervals. The effect worked for all sprites in the scene, rather than only the ones that changed. The simplest way to deal with it would be a sleight of hand trick, where I would create two similar sprites for each reaction and change both sprites every time. Another would be to always change sprite scale during changes and add some dynamism to the dialogue and pretend that the reappearing is not a bug but a feature. But both of these solutions create certain limitations that would be very easy to violate by accident in the future, so I decided to actually put in the work and create a working system. The issue was caused by how my initial system was set up. It checked if the sprites changed since the last line, and if they did, then it erased all sprites from the box and then populated it with new sprites. Since the fade-in effect was called on construction of the sprite, it fired off every single time, no matter if the sprite was new or the same as before. So I had to change the way my system was loading in the sprites. The first version created the assets in the loop each time they changed, which made it quite difficult to address specific containers to change their images. I changed it so that the system creates the containers during overlay initialization before populating it with data, and then adds the container references to an array. Having an ordered structure allows me to iterate over it and change specific images. It creates another limitation. I need to keep the same number of sprites for each line, or else there will be an array indexing problem. Luckily, this is easy to overcome, as I can create a completely transparent sprite, and thanks to the stroke of genius that was adding the scale to the table, I can hide that sprite completely by simply giving it a scale of 0. This limitation is much better than the previous one, as all it requires me to do is carefully plan out my dialogues, which I intended to do either way to avoid continuity mistakes. Of course, since the sprites were now changed rather than reconstructed, I had to create a trigger to launch the fade-in effect every single time. And just as I was about to congratulate myself on a job well done, I remembered that there should also be a fade-out effect. The fade-out should fire off before the character disappears, which turned out to be way more difficult than I initially thought. Because I used functions, I couldn't use the delay node, which would allow me to just wait for the effect to finish. After changing the function into an event and adding the delay node, it still didn't work. For some reason, the fade-in node placed after the delay would launch before the delay. No matter what I did, I just couldn't get them to launch in the right order. But I wasn't going to give up. And so, after a walk, I came up with another idea. If I couldn't get the interactable object to handle the sequence, then why not have the sprite container do it? And so, I added some input to the container that would tell if it's the first run, which would skip the fade-out effect. I also added the new image input, so now setting the image would be handled between the transitions by the container, rather than by the object. This idea was a bullseye. Suddenly, everything worked exactly as it should. I'm a little embarrassed by how long it took me to implement simple fading effects, but whatever, it was time to move on to the final challenge. The text. As I said before, implementing typewriter effect is simple, as it just needs a free plugin from the Epic Store, unless you're using style tags. I was unwilling to give up on the tags, as using them would really go a long way in communicating quest waypoints and objectives to the player. Let's get right into it. Generally speaking, the typewriter effect is accomplished in a similar way as the fade-in effect. The difference is that fading slightly changes the opacity, while typewriter effect changes the fragment of the text that is shown. It starts from the first characters and then slowly reveals the entire text by passing larger and larger portion of the entire text into the overlay. So why are the tags difficult? Well, they require you to scan the text twice. Once to pass in smaller fragments into the overlay, and second time to find and handle the tags. Of course, the premise is simple. First, the function scans the entire string and finds the index values where each tag begins and ends. Then, the function once again scans the text bit by bit, just like before, only this time it keeps checking whether it's in an area affected by the style tag or not. When the scanner encounters a tag, it skips to the ending of the opening tag to avoid lags in the effect. Then, for each character in the tag's area of effect, after printing that character, it also prints the closing tag, which means the style is applied on the fly as the letters appear. When it encounters a closing tag, it stops adding it and once again skips to its end to avoid any bugs. Of course, my great plan turned out not to be so great after all, as the function kept adding the closing tag every single time, rather than only when it should. And so I encountered the part that took hours of my lifetime away. No matter how many times I checked, the logic seemed fine, and I had no idea what was causing the bug. I finally understood why the free plugin didn't work with style tags. So at some point, I started randomly messing with the nodes, until... I have no idea why it suddenly started working, but I'm not going to look a gift horse in the mouth, and I don't want to accidentally break anything, so I just left it alone. The last thing to do was to move the code from the test class I was using to make development easier to the real object. Learning from my character's fading implementation, I decided to move the typewriter effect to the overlay's blueprint, so that the interactable object can call it and move on while the effect happens. That way the sprites or CGs can appear at the same time as the text, so that the player can avoid waiting for something to load. There is some functionality I still have to add at a later time, but it isn't essential at the moment. One is remembering the player's choices, so that the world can react to them. I'll probably create an invisible actor that's loaded in every level and just keeps track of various variables, including players' choices. Doing that will also make it quite easy to save the state of the game by simply saving that actor. The second function is a history log, in case the player misses some text. It's quite simple to do. I'll just need to create a new overlay containing all the text that appeared before in the conversation, along with the speaker name. Populating that overlay is a matter of creating an array. Simple stuff, or at least I hope so. The last one is to create a skip button that the player can hold down to skip large amounts of text. Since I use variables for both text and image fade speed, it will be quite easy, as it simply needs to set these variables to ridiculous values and call the refresh function over and over. All of this is quite simple to do. And the only reason why I'm not implementing it immediately is because the uphill battle to get character fading and text typewriter effects to work made me feel like a part of my soul is dying every time I turn on Unreal Engine. I want to do something that you can actually see immediately, not just a framework for future use. So, in the next video I will create my own little character and make it run and jump all over the place. That's all for today. See ya.